Hello again everyone. I have a piece of vintage test equipment to show you today. Not only vintage, but actually historically significant. This is a Fluke Model 8020A portable digital multimeter made in 1979. This was the very first commercially successful portable digital multimeter. Fluke introduced this multimeter in 1977, and it was the first really popular portable digital multimeter, the first one that sold really well. This is a landmark device. This is the multimeter that all portable digital multimeters today are based upon. This is where it all started. I got this at school. I got two of them, in fact. They had left them outside the tech shop up for grabs. They were really filthy when I got them. I took both of them completely apart and actually washed all the plastic parts in the sink, and they came out really well. And I tested both of them, and they both work absolutely perfect, and they're both perfectly accurate, tested against my other multimeters. So that's really great, and I gave the other one to my friend Brandon, and he was very happy. It's his first multimeter. I do know that the school purchased exclusively Fluke multimeters up until, I don't know, probably the mid or late 1990s, and then they started buying Hioki multimeters. And then sometime not too long before I started going to school there in 2012, they bought a big round of multimeters from another manufacturer. I don't remember which it was. And we've been sourcing our multimeters from there since then. So this probably served a long and useful life in one of the labs at school. And in fact, we still have a bunch of AC-powered Fluke multimeters in use at school. One of the labs is filled with Fluke multimeters from the late 70s and early 80s. All the ones that still work are still in use. There is a bunch in that room that do not work, and unfortunately, last year when I had a couple of classes in that lab, we found that they were just dropping like flies. It seemed every time we went into a lab, there were 2 or 3 new ones that did not work anymore. So, they were starting to break down, but I think they're still in use there, what ones are still working. So, 1977, this was the first portable digital multimeter that sold really well. There were portable digital multimeters that came beforehand. They were not successful. For a variety of reasons. First of all, they were a lot larger, bulkier, and heavier than this was, because they ran on either rechargeable batteries or very large primary batteries. I haven't been able to find more than 2 or 3 examples of portable multimeters that came before this, but from what I remember, the ones I found, they ran on like C or D batteries, so they were really big and heavy. Whereas this, as you can see, it's about the same shape and size as a modern multimeter. This was when this came out, there was just nothing like this. It was so sleek and small and light and extremely stylish. If you were a technician in the late 70s and early 80s and you sported one of these, you were the cool guy in the lab, literally. Another landmark introduction with this multimeter was the battery life. Early portable digital multimeters, of course, sported LED displays, and I'm sure there were probably some that sported other early display technologies that used as much or more power. But I'm not sure, I think this might have been Fluke's first multimeter with an LCD display, but I do know this was obviously the first portable digital multimeter with an LCD display, and that was really important because LCDs, as you know, use almost zero power. So for the first time you had a device like this, and it had really good battery life, and it ran on a really convenient power source, the ubiquitous 9-volt battery, which is accessed under this door here. So this ran on just a 9-volt battery. You got extremely long battery life out of this thing, which was unheard of at the time. I've left this turned on accidentally once for 2 or 3 days, and when I found it and discovered that it was on, it was still working just fine, and it's still working off the same battery. Another reason this had such good battery life was, for the first time, tight circuit integration was used in a device like this. Fluke designed their own custom CMOS integrated circuit to do all the electronic work and to drive the display, and that had not been done before. Earlier portable digital multimeters were composed of basically off-the-shelf integrated circuits, like 7000 series ICs, and they were based on TTL logic instead of CMOS. TTL uses more power than CMOS. There's just one big integrated circuit inside this thing, which was an unheard of level of electronic integration at the time, and it was a custom CMOS chip, and it uses very little power. And there was just the absolute highest technology that was available at the time was incorporated into this multimeter. It was absolutely remarkable what they were able to do at the time. Another big advancement this multimeter introduced was durability. This multimeter proved itself to be extremely durable, and pretty much all of Fluke's multimeters are extremely durable, very high quality. I've used several different Fluke multimeters, and I think both in the past and today, Fluke makes some of the highest quality test equipment you can buy. And yeah, these were very high quality. And modern multimeters add a bunch of useful features that this one doesn't have. They can test frequency and capacitance and test diode voltage drop and conductivity and stuff like that, and those are all nice if you can use them. But when it comes to the basic 3 functions, voltage, current, and resistance, which is what this tests, you don't need anything else. And the people who used these back in the day are still using them. They have no need of buying a new one. Plus, with durability and never goes out of calibration, why would you want anything else? So yes, this is a very revered piece of equipment, so I'm quite happy to have one here. So let's take a look at it here. Well, on the left side is the power switch. I'll turn it on. There it is, all ready to go. It does have a negative indicator, and you've got your numbers, and you've got nothing else. Don't need anything else. As you can see, my unit is very yellow here. That's not the original color. The original color is sort of like this, but not even this. It's supposed to be a little bit brighter. Kind of a light gray. So, I don't know, I may try maybe retro bright someday on this plastic, but it's really no big deal to me. And you can see it's an extremely high quality LCD display. The contrast is just remarkable. And this was, I think this was Fluke's first multimeter with an LCD display. And remember, 1977, LCD displays were a brand new technology. It was only about in that time when LCDs were just starting to be incorporated on a good amount of electronic devices, and they were still very expensive and very difficult to manufacture. And as you can see, this one is still working just fine almost 40 years later. Mine's got a bit of a break in the plastic here. That's no big deal. The one I gave to Brandon had one of the screw lugs broken, so I think the plastic's probably starting to deteriorate a bit. Then again, this probably wasn't deterioration. This was probably dropped at one point. Heck, it's probably been dropped many times in its life if it was used as a school lab multimeter for 10 or 20 years. I have no doubt this has seen some abuse. Right there you have an AC adapter jack, which I find kind of funny. You paid the money for a brand new digital multimeter back in the 70s, and why would you tie it down to an AC adapter? It's kind of funny, but it's there if you want it anyway. Retail price on this in 1977 was 170 American dollars. Using the US inflation calculator, that's about $670 today. so it wasn't terribly cheap. So you've got your three standard banana plug jacks here. You've got your common, your plug for voltage and resistance, and one for current, same as a modern multimeter. And you can see here NS, that's nanosiemens. Siemens is the unit of conductance. This does not measure conductance, however it tells you how to do it yourself if you want conductance. It's just 1 over the resistance. So, fair enough. And as you can see, we don't have a rotary dial. We have the classic Fluke switches here. That's used on a lot of Fluke multimeters, almost all of them. I've read that back when this multimeter came out, other manufacturers started copying this switch dial. However, I've never seen another multimeter that has this switch dial. I've only seen it on Flukes. So, and you've got a couple of switches that are toggle switches like that. This does have one kind of little oddity in how it works. To measure voltage or current, you leave this switch out and then move your red lead to either here if you're measuring voltage or here if you're measuring current, and then to measure resistance you push it in like that, and now you've got resistance. And then for AC or DC, out for DC, in for AC. So you don't have to have separate voltage modes for AC or DC and separate current modes for AC and DC. You just use this switch. Very nice. So this can measure AC current, which I really like, because a lot of, inexpensive multimeters, even today, they can't measure AC current, and I do like a multimeter that can measure AC current. And then of course you've got your ranges, and it's labeled here: ranges for current, ranges for volts, and range for resistance. Volts, your good, your finest scale is 200 millivolts. You can go up to 1,000 volts DC or 750 volts AC. Resistance, 200 ohms to 20 megohms, which I've never seen a resistance level that high on a multimeter, 20 megohms. And then current, your good 2 milliamps to 2 amps. So this can't measure very high levels of current, only 2 amps maximum, whereas your ordinary multimeter today can measure usually up to 10 amps. The 8020A was discontinued in 1984. It was replaced with a model called the 8020B, which looked mostly the same. It added a couple more functions, but it had the same switch layout, and it was mostly the same as the 8020A, and the 8020B lasted until the late 1980s, I think 1988 or 89. So very impressive. If we look on the back here, it says battery eliminator jack, which is right there. Caution, operational hazard exists if battery eliminator other than Fluke A8i or A81, whatever that says, is used. Caution, this instrument contains no operator serviceable parts, screw removal by qualified persons only. This is a little stand that flips up, and you can stand it up, very nice. Under the stand it says, John Fluke Manufacturing Company, Incorporated, Seattle, Washington, and this was made in the USA. No surprise. Warning, do not operate instrument unless battery cover is in place and fully closed. Another warning, remove input signals before accessing 9-volt battery or 2-amp fuse. So if we remove this battery cover, which takes a lot of force to do, you gotta push down and outward, like that. There's our 9-volt battery, and as you can see right there, we can actually replace the fuse. You don't have to take this thing apart to replace the fuse, which I really like. So there you go if you want to replace the battery, and your fuse is also right there. Very nice. I guess I can do that, no problem. I'll open this thing up and show you the inside. This is very easy to take apart. You got a screw here, and screw here. Once your screws are out, the front faceplate lifts off like that. And there's probably the best representation of the original color of the device. So here's the inside of this thing, and you can see how the display is built there. This plastic shield actually comes out, so you have direct access to the display. So that's nice, you know, you can have something impact the display and it won't damage the LCD. And you've got this little metal, this metal coated flap here, which I guess serves as a grounding to ground the whole device. And you do have trimmers to calibrate the AC voltage, DC voltage. HF adjust, I'm not sure what that means. HF I assume means high frequency, but I don't know the context of that. But I haven't had to touch any of these. This thing has been spot on through all my testing. And there you can see some of the circuitry there. There's the switches, and you can see what this switch mechanism looks like. I did have a minor issue with this particular unit, but not the one that I gave to Brandon originally when I got it, that I fixed. And that's that sometimes when you went to press a button, the button wouldn't stay in. It would pop right back out. You could press it and press it and it wouldn't stick in. And it turns out what was happening was, if you see this little metal flap right here, when I change settings, you can see it bends up a little bit and then snaps back down. And that's kind of acting as a spring, such that when you push in a switch, that spring pushes down on a lever which locks the button in place. What was happening was the lever itself was getting stuck, so the little spring was pushing down on it, but it would not budge. So what I did was, I didn't know what to do, and I actually asked on Reddit. I forget where on Reddit though, and I never got a response. And I couldn't find anything about this issue. And I was at a loss and really had nothing to lose, because this thing was practically useless because the buttons wouldn't stay in. I just took some oil, 3-in-1 oil, and dripped it down the little hole where that spring is, and that fixed it. It works perfectly. So if you have a Fluke multimeter whose switches will not stay in, just take some friggin' oil and drip it down inside the mechanism through that little, you can't see it on the video probably, but the little slit where the little cantilever type thing is. There, you can kind of see the lever it pushes down on. Drip some oil down there, and that fixed mine. Sweet. A little 4000 series CMOS logic chip there, RCA. And you can see the date code there, 919, 19th week of 1979. A quartz. Yeah, I just noticed this. That's remarkable. Look at this quartz crystal. Look at how huge it is. That's the hugest quartz crystal I've ever seen. And you know why? Look at the frequency. 50 hertz. A 50 hertz quartz crystal. I mean, I think the slowest quartz crystal I've ever seen was like a few dozen kilohertz. I didn't even know you could get quartz crystals that low of a frequency. A 50 hertz quartz crystal, I've just noticed that now, and look at how huge it is, the can on it. Wow, that's cool. This flexible shield is actually epoxied into the back half of the case. So you've got to remove that screw, the flap lifts up, and then you can remove all the circuitry. And under the display is the main custom Fluke IC that powers this whole thing, and it's socketed, which is remarkable. It's socketed, so if that were to ever, and of course they did that for a very good reason, if it ever failed, the whole multimeter's done for. But you know, you send it into Fluke for repair, and they would just yank that chip out, stick a new one in, and you're good to go. You don't see serviceability like that anymore. I would assume that you can't get that chip anymore, so if that ever goes bad, it's curtains for this thing. just the way it goes with custom ICs. And there's the inside of this thing. Oh, these little switches, they pull right off, and I gave those all a bath too. This whole thing was covered in grime. Just, I would assume, 40 years of grime. So let me put this back together and do a couple of sample measurements on it just so you can see something display something other than 0. And we're back. Oh look, a battery. There's the voltage of this battery. Oh look, a light bulb. Resistance. Switch goes in. We get 26 ohms. Put it down in the next range down. 27 ohms. Resistance of this light bulb. So there you go. There's a little demonstration of the thing. And there you can see it's open circuit. If I grab the wires with my hand, do that. Grab the wires with my hand. And there's a resistance across my finger. The last thing I'll do is I'll read an article that Fluke themselves actually wrote about this multimeter in recent times. So this is a little article that you can read on Fluke's website. They wrote it in 2004. It's 4 pages long. Unfortunately, only the first 2 pages are actually notable, and then the second 2 pages are just poorly masked advertising for their newer multimeters. The little gray box that started a revolution, more than 25 years of Fluke multimeters. And there's the 8020B. That's what that looks like. Technology at work. Should start at the beginning there. There it is. It wasn't as big as the Space Shuttle Enterprise. It wasn't as flashy as Star Wars. For electronic technicians, that didn't matter. The Fluke 8020A digital multimeter made big news in 1977. Traveling in hip pockets and tool bags to the most inaccessible job sites, it proved to be accurate, reliable, easy to use, and tough as a rock. And it made the technicians who used it look good. The Fluke 8020A, the world's first successful handheld DMM, gave field technicians the troubleshooting capabilities once reserved for lab specialists. It changed Fluke's focus from a maker of bench test instruments into the world leader in handheld electrical test tools. In the decades that followed, the 8020 and its successors would earn their keep in the world's most challenging workspaces and build incredible loyalty among some of the world's most demanding technicians. Quote, "It's still my favorite just because I've had it so long," says Jack Nugent. Nugent and his team can choose from an arsenal of Fluke DMMs, and his 8020A, purchased in June of 1978, still resides in his personal toolbox. Imagine still using other 1977 technology, like the Apple II computer, Atari 2600 video game, or a first-year VHS video player. Secret, the newest and best technology, born into an era of remarkable technological advances. The Fluke 8020A used the newest and best electronics technology. That was its secret. Existing components couldn't deliver the required combination of high performance and low cost, so Fluke designers created a custom complementary metal oxide semiconductor, or CMOS, analog to digital converter chip to drive its liquid crystal display. The electronics packaged into that little gray case proved to be highly accurate, within 0.25% of reading plus or minus 1 digit. Light on battery use, reliable, and durable. Visiting trade magazines to show off the new product, Chuck Newcomb would accidentally let it slip from his hand to show off its toughness. One editor nearly broke his neck trying to keep it from hitting the floor, Newcomb laughs. He missed it, but I just picked it up and continued with the demonstration. I knew it would still work, and it did. If the 8020 impressed the editors, Electronics magazine ran a 6-page technical analysis. It made an even bigger splash where it really counts, in the field. After just a day of use, competing meters with an LED display required an overnight recharge. The 9-volt battery in the 8020 lasted through 200 hours of testing. Its LCD display was designed to optimize visibility and response, even at low temperatures. To protect against high voltage transients, the 8020 used metal oxide varistor clamps in combination with input resistors designed to fail as an open circuit to protect the meter and its operator. That little gray meter delivered a mix of performance and price, $169 American, that made it an instant hit. Before the 8020A was retired in 1984, more than 250,000 were sold, and the 8020B, with 5 additional models based on the same technology, brought the total to 1 million units by the end of the decade. Combine that with over 2 million 70 series meters, a new design introduced in 1983, and Fluke was in the handheld test tool business big time. And then after that, it just starts basically telling you that although the 8020 was great, it's obsolete now and you should buy our new multimeters. Which I think is kind of sad that they fell to that level after the first page of the article, but that's how it goes, I guess. So that is the Fluke Model 8020A portable digital multimeter from 1979, the first successful portable digital multimeter, a landmark device in its time, basically the ancestor to all modern digital multimeters. And really glad to find this very good condition, perfect working example. And I shall make use of it, for sure. This is the the 4th multimeter I have now, but it's definitely the most interesting. And the 2nd most useful. I've only got one other multimeter that can measure AC current, and this can measure AC current, so that definitely makes it very useful for me. And it's just a very nice piece to have. So I hope you guys have enjoyed this little look back in history, and have enjoyed taking a look at this vintage piece of electronicry. So thank you very much for watching, and I will see you later.